This video is going to go over the different things that has to happen for a solid to become a liquid to become a gas to become a liquid to become a solid, and those changes in our different phases. And again, we're only going to focus on solids, liquids, and gases for the purposes of this class, but just always know there is a fourth state of matter, which is plasma. So what happens during a change of state? So during a change in state, what happens is the amount of kinetic energy, so remember the energy involved in particles moving, is going to change, right? So by adding or removing heat, which is thermal energy from a substance, we can change its state of matter. So thermal energy, which is just the fancy scientific word really for heat, is the total amount of kinetic energy of all the particles in a substance. So when we add thermal energy to a substance, or we add heat to a substance, the kinetic energy of its particles are going to increase. When we heat something up, the molecules in a solid, liquid, or gas are going to start moving faster and faster and faster. If we cool it down or we remove heat or thermal energy, then the kinetic energy of the particles are going to slow down. They're going to start moving a lot slower. So by changing the amount of thermal energy, we can actually change or force an object to go from a solid to a liquid, or from a liquid to a gas, and then back again. So this is called a phase change diagram. You're going to actually be making one of these for a compound of your choice on one of the assignments. But you can see here that this is temperature along the side, so as temperature starts to increase here, and this is heat energies, right? So we're adding heat energy going this way, we're increasing temperature going this way. And you can see that there's going to be a period of time, a period of temperature where something can remain a solid. So let's just use water, for example, because we all know that water can go from solid to liquid to gases, right? So solid water would be an ice cube, okay? And there's going to be a point of change here where that ice cube is going to start to become a liquid, where it's going to warm up. We're going to add thermal energy to it. Those molecules, water molecules, are going to start moving faster and faster and faster. And at some point, it's going to become a complete liquid. Now, this process doesn't happen instantaneously. You know, if you put an ice cube on your countertop, it's not going to melt in a second. It's going to take a period of time before it completely becomes a liquid. And that's kind of what this plateau here is. It's this phase change as it starts to melt. Then, if we continue to heat up that liquid, heat it up, put it on the stove, add some heat to it, those particles are going to start moving faster, faster, and faster. And at some point, we're going to create steam, right? The liquid's going to start to become a gas. That's what steam is. It's water in a gas form. And so as that water starts to become a gas, then those particles are going to be moving faster, faster, and faster until all of the liquid ends up leaving in its gaseous form, and that would be water vapor, okay? So vice versa, we can take water vapor, for instance, that's in the air, and we can cool it down, and turn it into a liquid, cool it down, and then turn it back into a solid. So think about like going from water in the air to, let's say, rain to snow, all of changing from a gas to a liquid to a solid just because we've decreased the amount of heat. All of these points here are going to be very specific for a specific compound. So the point at which water becomes a liquid, the temperature at which water becomes a liquid, is different than, say, the temperature for carbon dioxide to go from a solid to a liquid. The temperature needed for water to go from a liquid to a gas is going to be different than, let's say, nitrogen gas or nitrogen going from a water or a liquid to a gas. So each individual compound is going to have different temperature ranges, which we're going to talk about melting points and freezing points, that will lead to a phase change. So when you look at this graph, again, it's kind of just important to note that there are these plateaus here, so between A and B and C and D, and we kind of talked about that. And that's just because, you know, this process of changing states does not happen instantaneously. So What causes a change of state? As a checkpoint, any kind of substance that gains or loses thermal energy, aka heat. So what are the changes in state between a solid and a liquid? So this is called melting, right? It occurs when a solid changes into a liquid. When there's enough heat that's added to the system, it causes the particles to speed up and go from this packed-in solid structure to a more loosely structured liquid. The temperature at which a melting begins is called the melting point. And so the melting point for a substance is the same temperature no matter how much of the substance you have. If I have a tiny ice cube versus a huge ice block, the melting point is the same. It doesn't matter how much substance is there. Freezing point is going to be when a liquid turns into a solid, so going back the opposite direction. So the freezing point of a substance is going to be when the particles slow down enough until they become in a fixed position and only vibrating in place, shaking in place and not necessarily moving around, making them a solid. So melting point going from solid to liquid, freezing point going from liquid to solid. So between liquids and gases, condensation is when a gas changes to a liquid, right? And you see condensation all the time when you wake up in the morning and you see dew on the grass. Dew is going to be when the water vapor in the air is going to cool down because of the night temperatures and start to change into liquid that lands on the blades of grass and on your plants. Vaporization is when a liquid changes to a gas. So there are two types of vaporization. There's a boiling point. So this is the temperature at which a liquid boils, and boiling takes place throughout the entire liquid, causing steam to rise up. And then there's also evaporation, and this takes place only at the surface of a liquid. So, and evaporation can take place at different temperatures. We really want to just focus on boiling point for our practical purposes because this is going to be when all the liquid starts to become a gas versus evaporation, which happens more in stages. There are some other changes of states too that should be mentioned. Sublimation is when a solid becomes a gas. So basically it skips the liquid stage and it goes directly from a solid to a gas. And this example of this would be dry ice. And then deposition is when a gas becomes a solid, and that's going to be when frost forms on a leaf. So again, both of these situations are going to be a change of state, but skipping the liquid stage. So checkpoint 3, what changes of state occur in each of these examples? A water droplet from outside your cold glass on a hot day. So that's going to be going from gas to liquid, so that would be condensation. A puddle forms after it rains, but it's gone the next day. Well, that would be evaporation. It's going from a liquid to a gas. And after leaving your chocolate bar in a hot car, it no longer has its solid shape. That's going to be melting. It's going from a solid to a liquid. What are some similarities and differences between solids, liquids, and gases? Just to tie it kind of all together. Well, the particles of each state of matter are always in motion, so that's something that all three states have in common, right? It doesn't seem like solid particles are moving, but they are. They're vibrating in place. Liquids particles are moving around, flowing around each other. Gas particles move around a lot more, flow past each other. So gases have the greatest amount of kinetic energy, meaning that the molecules in a gas are moving around a lot more than they are in a solid. So those are the changes of matter.